All right, nothing really new in this video. We're just going to get some more practice. Example 1 says, after retiring, you want to be able to take out $1,000 every month for a total of 20 years, again, from your retirement account. Okay, the account earns 6% interest. How much will you need in your account when you retire? This person is chilling. Our example 0, they were living off of almost 4K a month. They were feeling pretty good retired. These people are much more frugal. Okay, these people say, I retire. I've already got my house paid off. I'm gonna just have my kids feed me or whatever. $1,000 a month will be fine. I'll be fine. So these people are more frugal than example 0. I don't know. Let's go. So remember our equation. We go up here. Oh, it's a messy equation. Let's just write the whole thing down again. All right. Whenever you use a messy formula, it's usually best to just write it all down. W times 1 minus 1 plus r over k to the negative kt. Kt all over r over k. Once we write it down, we just make sure that we copied it correctly. We get the parentheses in the right place. Everything looks pretty good. And now that we have it here, it's going to be much easier to use. Okay. We want to be able to take out $1,000 every month. That's our W. Total of 20 years. That's our T. R is related to 6%, 0.06. And what's K? It doesn't tell us how frequently it compounds, but we are paying every month. The K is 12. Now we just plug everything in. P is how much we're going to need. Withdrawing $1,000 times 1 minus 1 plus R over K, the negative K times T, all over R over K. And again, messy formula, but just typing it into an online calculator can make this a little not as bad. You can be really lazy and edit previous answers too. Just make sure you edit it correctly. Wait, I think that's it. I think everything else is the same, right? We double check that our laziness is not getting us into trouble. And we look good. All right. So now if we're going to be real frugal, we only need 140K. Oh, okay. P should be about 139, 580. 0.77. Yeah. Now that is a retirement amount I can save up for. All right. And now what we could do, we could combine both sections, right? We could combine both sections to say, okay, if I'm planning on retiring in 30 years, how much do I need to put in my account every month? That becomes a 6.2 problem. These are all questions that you can ask yourself as you're preparing for the future. Or there are a lot of online calculators out there that will do this for you. But this is where the math is. Let's look at a weird version of one of these problems. We have a donor. They give 100K to a university and specifies that it is to be used to give annual scholarships for the next 20 years. Right off the bat, the university can use this money. It can invest this money. Because if it didn't invest this money, right, each year would only be able to have $5,000 of scholarships. But if we invest this money, we can take out scholarship money every year, and the rest will be earning interest while we're not using it. All right? And then we're going to be able to use a lot more than $5,000 every year. So this is also another way of seeing a payout annuity. Let's copy that formula down again. P is W times 1 minus 1 plus R over K, and the negative KT, all over R over K. Again, anytime you're using a messy formula, whether it's a quadratic formula, annuities formula, compound interest, loans, whatever messy formula you can think of, it's a lot easier to plug it in if you copy the formula down right here. All right, and here, oh, so now the total, that P is up here again, just like we did before. 20, that's our T. Interest, our R is 0.04. Oh, annual scholarships. K is only equal to 1 here. Usually it's monthly for a lot of these applications. But now it's annual, so it's K is just equal to 1. Let's see what everything becomes. We get 100K. Is W, we don't know how much we're giving out in scholarships every year. 1 minus 1 plus R, which is 0.04, over K. The negative K times T. K is just 1, so that's nice. And then just like before, it looks real messy. But all this is saying 100,000 is W times this big red box. Big red box, just the number. Find out what this number is. All right. If we go over here, it's 1 minus 1 plus 0.04 divided by 1. Negative 1 times 10. 0.04 over 1. Then let's double check, compare. Make sure that we're typing it in correctly. We didn't type it in correctly. We typed it incorrectly, but we didn't type it in correctly. It'd be 20 years. All right. So that big red number, 13.590. Real messy. It doesn't look too bad now. Divide both sides by that 13, we'll get our answer. So let's say 100K divided by 13.590. We get not 5,000 a month because we're being able to profit off the interest that we're not using. So it's more than 5,000 a month. It's actually 73.58, almost 50% more than we originally thought because we're investing it. So investing the money that we're not using means more money in the future. So 73, 58, 35. And again, just, kind of a good rule of thumb in general. Important to have, some liquid assets, some money that you can use in an emergency. But investing is usually going to be better for long-term stuff. All right. And there we go. That's cool. That's the section. This was the happy section. Next section, we're seeing the other side of the same coin. And it'll be less happy. Tune in next time for math videos. Bye-bye.